Now to the third part of the lab, which is an RL circuits and integration. So the input is a square wave with a 2 peak to peak and goes to an inductor, and we only have here in the lab 2.7 millihenry, so we'll be using this for all of the three circuits, and then in series with the R and then to the ground. The output is across the resistor. So here I'm using 4.7 kilo ohms, 1.5 kilo ohms, 560 ohms, and 2.7 millihenry inductor for all of them. So tau for RL circuits is L divided by R. So tau 1 is this value, and here's tau 2, here's tau 3, the time constant. Here's the circuit. So the input from the function generator, here's the ground, and here's the input, goes to the inductor, and then the inductor in series with the resistor to the ground. Output is across the resistor. So here's the output, the 10 to 1 probe. So now for the function generator, it's a square wave with an amplitude of 2 peak to peak, and the period should be 12 times the expected tau. So for the circuit I'm using, it's the 1.5 kilo ohms and 2.7 millihenry. Tau is 1.8 microseconds, and 12 times tau is 21.6 microseconds. So tau here is 21.6 microseconds. I mean the period. Now apply signal to the circuit. So here's the output. This is the input square wave, and this is the output, the integration waveform. So for the integration, we want one of these parts. So let's turn off channel 1. Maximize this part. Now press cursors and choose cursor X1. X1 should be at the very bottom, X2 at the very top, now read delta Y, which is 1.75 multiplied by 0.632, which is 1.106. Move cursor X2 until delta Y equals 1.106. And then delta X is tau. Delta X is 1.74, and the expected tau is for this circuit is 1.8 microseconds. Let's try the third circuit, which is the 560 ohms and at 2.7 millihenry. So for this circuit, tau is 4.8 microseconds, and 12 times tau is 57.8 microseconds. So on the function generator, the period should be 12 times tau, which is 57.8 microseconds. not showing the right waveform. So let's check again. So this is the 560 ohms. So 560 ohms times 2, or tau is 2.7 divided by 560 is 4.8 times 1257. Let's check this resistor using the digital multimeter or the multimeter. It's 560. Maybe it's from this inductor. Let's use another one. Yes. So it was a defective inductor. So now auto scale. So this is the output. We want one of these parts. So turn channel 1 off. Channel 2. Then use cursors. Cursor X1. Cursor X2 at the very top. Read delta Y, which is 1.67 multiplied by 0.632. Now move cursor X2 until delta Y equals 1.05. Now delta Y equals 1.05 and delta X is tau, which is 4.55, and the expected tau is for this circuit is 4.8. That's it for the third part of this lab.